welcome to our talk, Integrating Systems in the Age of Quarkus, Knative, and Kafka. So, I am Zineb, and he is Peter. We are both working at Red Hat within the teams that work on projects around integration. And both of us, we work on the project, an open source project that is called Apache Camel. And more precisely, what we do in our daily job is that we develop and maintain Camel extensions for Quarkus.
Oh, sorry. In this slide, I was trying to sketch the integration problem. And I think this picture illustrates it very well. First, there is a frustrated user. And second, there are two systems that were not designed to work together. And that's basically the problem of integration, bringing systems together that were not designed to work together. And as a part of the solution, we want to offer Apache Camel today. More technically, what Apache Camel does is implementing so-called routes. Those routes take data from some source system that is sometimes also called consumer and push them into some sync system that is sometimes also called producer. Okay?
In the era of clouds, our apps tend to need to connect to more and more external systems. And it's challenging to master and know all the APIs for those external systems and all the protocols that they are in. Apache Camel makes it easier, simpler, and quicker to connect to almost everything. And to do that, Apache Camel offers a large library of connectors. As you can see, we have more than 350. And those connectors are also called Camel components.
So let's look a little bit closer what's inside, because this is the real base for the long-term success of Apache Camel. By the way, who of you knows Apache Camel already? Okay, thank you very much. And so for the rest, I think this talk is supposed to be interesting for both people who know Apache Camel already, for the ways how can it be used on top of Quarkus and Kubernetes, and it's also a good introduction into Camel itself. So what we have inside, on one hand, we have things like reading various file types, office types, flat files, and so on. Then we have connectors for taking data through various protocols, then some well-known public clouds such as AWS, which we are going to demo today, and many others. Then we have APIs such as GitHub, Jira, Telegram, and so on and so on. If you are interested to see the full list, we are posting, you can follow this link, and we are going to post the slides after this presentation on our Twitter handles, which can't be read well here, but we can somehow switch to a view where you can see the handles.
Yeah. So connecting systems, to connect into an external system is not enough, because when we connect, we have the data, we exchange data between external systems, and we need sometimes to, for example, transform this data if the schemas or the type of the data is not the same. So this is an example, but we can have multiple kind of operation that we want to do when we have to integrate systems. And most of those kind of operations are already described in the Enterprise Integration Patterns book that was written like before Apache Camel.
By the way, who of you knows when Apache Camel started?
It was in, I think, late of 2007. So it's a
pretty old Camel at the moment.
That adapts with time, like we're going to see today. But the thing is that, for example, we have message filter, content-based router, which we're going to route the message depending on what contained in the message, aggregator, filter, and there are so many that you can read in the book or go in this website to see them. The thing is that when Apache Camel is one library that implements most of those, and it's good to have them when we have those integration problems, because what we see generally is that people do reinvent the wheel each time. So it is better to have look at those, what was the best implementation, and use the libraries that already implement them and that implement all the use cases, how to handle errors, etc.
Now, how do we implement those camel routes?
Yeah, not that this language, because we said that Apache Camel makes it easier. So how this is done is by giving us a DSL, a domain-specific language that is quite intuitive for people. So Apache Camel would do so many things under the hood, implementing the patterns, implementing the router that would go look for those routes and make the data flow as described in the routes, and connecting to those external systems that have their protocols, their APIs, etc. And if you see here, we have so many languages like we see in the list, but here we have the same route written in Java and written in XML. And as you see, you can read it very easily.
The font is perhaps a little bit small, so we maybe read what's there.
Yeah, we have here from AWS to S3, so we are consuming from an S3 bucket. We have its bucket name, and we consume all the files that have prefix hello.txt, txt maybe.
I think there will be a bit more examples of this during the presentation where you will be able to read it better, like on this
And
slide.
then we just log, and then we just push it with Telegram in using a bot. What we wanted to showcase here is that from Java XML, the keywords are the same. So if you are using YAML or Groovy or Scala, you're going to have the same keywords, and it is very intuitive, and this is only what we need to do for this route.
Now let's speak about running Camel.
Camel runs on a lot of platforms. Like you can see, there is standalone. The standalone is for standalone Java. We have Quercus, Knative Kubernetes. We have Kafka, Connect, Spring Boot, and go on. Today we're going to talk to you about Quercus, because it's not our project, and also about the Knative Kubernetes.
So let's start with Camel on Quarkus. And let's start with explaining how Quarkus works. There's a lot of Quarkus content on this conference, and especially today. But anyway, I'm going to sketch how Quarkus works so that we have some basics, so that you understand what's going to happen during Zineb's demo. So at the very beginning, there's your code, the code of your application, the implementation of the Camel route. That code combined with the JDK code is an input for Quarkus Maven or Gradle plugin that augments your code or the compiled or the original bytecode into so-called enhanced application bytecode. I'm not going into too much into details what that augmentation means, but important for us at this point is that this is still bytecode. It's a bit different like this one, but it's still bytecode, right? And it means that it can be run on a stock JVM, such as Hotspot. And as another option, it can be passed on to a GraalVM compiler to produce a native executable. So this is, there are two inputs for GraalVM, not only the bytecode, but also some configuration that is prepared by the Quarkus tooling, and it happens basically under the hood, fully transparent to the programmer, because that's done by Quarkus extensions. So it's very important to stress at this point that there are two ways to run Quarkus applications, in JVM mode and in native mode. What's the difference? This one is fast to compile and a little bit slower to boot at runtime. But this one is much slower to compile because native compilation of GraalVM takes minutes for simple applications, but it's super fast to boot in production, right? So as long as you are developing, you go this way, and when you are done, then you compile to native, okay?
But why? Why using Camel and Quarkus?
Sorry.
Yeah, we're both using. Because we will have a small size on disk for our apps, so we can have small container images. We have fast boot time, so when we are on Kubernetes, it can instant scale up. We will see later how fast the application will start. And because we will have low memory footprint, so we can put more containers with the same amount of RAM and the same amount of money.
Now let's speak about what's the relationship between Camel and Quarkus, right? To be able to run these Camel components or to use the Camel connectors on Quarkus, they have to be packaged in a special way for Quarkus. The packaging is called Quarkus extension, and the project we both are most active is doing exactly that, taking Camel components and packaging them as Quarkus extensions, adding code that analyzes these input components and adding GraalVM native configuration and things like that. It's important to note here that these Camel components live in org Apache Camel namespace, and these here live in a different namespace that you are supposed to use when you want to run Camel on Quarkus. If you could please follow the code quarkus.io link, Zineb. So this is the generator of Quarkus applications. We already passed the Camel filter through the link. So here, if you scroll down, you see all the Camel Quarkus extensions that are hosted here. But these are not all. These are only those ones which are also supported in the native code. Please go back. And if you want to see the complete list, including the extensions that are GVM only, you would go to Camel Quarkus documentation, where there's the complete list. As you have seen, there's around 91 out of 313 not ported to native yet, and you may ask why. And the answer, the most common answer, is that nobody had time to write a test and figure out if it works in the native mode and what's missing, or there are known problems and it's hard, like in the case of CXF. When I go to conference and present this, usually somebody comes and asks me when CXF is coming to Quarkus. And maybe now there's a good chance that it comes finally because we have a pull request from the community.
Yeah. So now there's the demo. I don't know if you have Telegram, because we were going to use Telegram. If you want to help us with the demo, we have a QR code there if you want to join our Telegram bot. So this is the Camel Quarkus demo, so the first part of the demo. And we are going to have two Camel routes. We're going to develop two Camel routes. The first one will be the route that we will develop a Telegram chatbot. And this Telegram chatbot will gather messages from the audience and push those messages into a Kafka topic. And the second route, it's another Camel route that will consume those messages from this Kafka topic and push them in S3 buckets. And of course, when you got the slide, you will have here the link of the demo. So now I will stop sharing. And so to create the app, I usually go to code.quarkus.io because I love using the website. You can do otherwise if you want. You can see, for example, using the Quarkus CLI if you want. You can see the Quercus. So here we are on the Quarkus platform where there is the extensions for Quarkus plus the member of the platform. So as Camel, we are a member of the platform. So as Peter said, we have our extensions. And for example, here I choose Telegram. I select Telegram. I can use S3, and I will and so on. So all those ones that I use, and then I generate the app. If you have already an app, for example, a Quarkus app, and you need just to add to the pom.xml this extension, you can also come here and look for it. And from here, so I don't see it, but yeah, here. You can, for example, copy the pom.xml dependency snippet, and you will make sure that you don't see it well, but the Camel Quarkus extension. So I have already created the app before. So it is already in my IDE. So here is the pom.xml file that was generated by the code.quarkus.io generator. And it contains the Quarkus platform BOM that would contain the extension of Quarkus, and also the Quarkus Camel BOM, because it knows that I search also for Camel extensions. And then when we have this, you just have the dependencies. So it's created me the dependencies, but I can add any other Camel Quarkus dependencies because there is the BOMs there. I don't need actually to put the versions. So here I have Telegram, I have the Kafka one, all the ones that I need. In the project also you will have the Docker files in case you want to build the Docker image, and you have here the explanation, so you don't need to create this yourself. I created a class that I named routes. This is the name that I chose. This class will contain the Camel routes. So when you have at least one single Camel extension in your pom.xml, the Camel router will start and will go look for any class that extends this route builder class, and go to this method that we override, that is configured, to look if there are some routes that needs to be loaded, and it's gonna load these classes while we build the application. So here, so there is another thing. Well, it's Telegram. Let's go to Telegram app. So here I'm looking for my bot that is named Camel Quarkus. The first time we interact with the bot, we have a button start. And this one, what it does send to the bot a message that is, I don't know how we say /start. Is it in English slash? Yeah, okay. So this is not a real message. After that, I want to send a new message, hello world. Sorry. And at this point, the bot doesn't do anything, because when we create the bot in Telegram, we have an authorization token, and we need to create an app that uses this authorization token in order to interact with the user. So I am going to use a Camel consumer in order to consume those messages that are coming from the users. So to do a consumer, we use the keyword from. And here, the syntax is that we use Telegram bots. And for a first step, I will just log the body of the message. The message is an exchange. In Camel, it has body, which contains the message, and it has headers for the context of the message. So here, what I need is the $body, this way. And now I am going to start the app in dev mode, Quarkus dev mode.
Okay, while Zineb is starting in dev mode, maybe I can explain what dev mode means. Dev mode is a special module of Quarkus Maven plugin, and it compiles the application that Zineb has in the workspace, and it boots the application, and it keeps it up, watching for the changes in the workspace. And when Zineb now is going to make some changes in her application, the Quarkus tooling will notice, will recompile and reload the application.
Yeah. So here we have already some messages. We have 3 starts and my hello world. Just in order, I don't know, who knows Quarkus here? So for the ones that doesn't know, we're going to show very quickly the dev mode. So, you say incoming message is. Oh, hello Zineb, thank you. and here it's reloaded, and we have a new message. Hi from London, and you see that we have now incoming message. So, did you happen to? The question is how it knows that it's the bot Camel Quarkus. We have too many ways to configure the Camel components. I went for the one in application.properties, and we just have camel.component. Then here we have the name of the component, and we take the property from the documentation of the Telegram component in our website. And here, because I didn't want to share the token with everybody, I put them in environment variable, and this is how we use it in the application.properties when we are on Quarkus. So this is, when I put it here, every route that will use a Telegram component in my app will take this authorization token.
And there are some more properties here, like for AWS S3 that we will need later.
Yeah.
And there's some special configuration item for the messages that we want to send to the users via the Telegram bot.
And this
like
is what
there's
we
a
are going to
separate
do
welcome
now.
message
Yeah.
and a thank you message.
Yeah. Yeah, so here I have 2 messages because we didn't want it to print them. It's too long. One for when we have the start and when we have a real message. So the idea, what we are going to do, because now the bot receives messages but doesn't interact with the user. So we're going to send the message, so produce a message. But because we want to do a separate message if it's a start or if it's a real message, we are going to use an integration pattern that is the content-based router, and this one will have choice. So I will not type everything, but I will just copy it from here. So we add a new step, just making it a little bit more fancy. So as you see, it's a choice, and we can have one or multiple when, which are the condition, and we can have an otherwise. And here what we do, we just transform actually the message and use in here with placeholders the one that the messages that I have in my property file. The is start, actually we will have a Java class I will show you later that is generated from the consumer that can have the text, but can have videos and all the stuff that we can receive at Telegram. And it contains the text. And this predicate that I used Camel JSON path in order to test if my text is equal to the /start. So I am using this one. And now that I am transforming the body, so the body that I received, I transformed it completely to have the response, the reply response. So I'm going to just use the same syntax, but now for a producer to respond to the user. And because we are in the same context, Camel will use the chat ID of the user that we consume the message from. So it's bots with S.
So throughout this integration route, there's some message object flowing through. It has some headers and it has some body, and that's what we are interacting with here through the Camel DSL.
So here, if I test, when I do start, I have the first message. When I send a message, it tells me, thanks you for your message. Now, this when we have a message, we want to transform it to a new format of message that is simpler. We want to push it to Kafka so that we can then consume it and push it to AWS3. So I would come here to otherwise. I have to push the message before I transform the body with the reply message. And what I want to do, I created a Java class here with one method that takes the Telegram consumer message that contains the text and everything, and I just create here in my method a new object for this class that have only ID of the message, the text, the first name of the person. We're not keeping your chat ID and your last name in case, and we will have just your first name and a date.
So we are doing some basic transformation using our own code that is not Camel DSL code. Yeah. And this is supposed to demonstrate how you can plug in your own beans that do some logic into the Camel DSL.
So I'm going to use the extension that is bean to use Java beans. If I have multiple methods, I have to specify method, but when we have one method, we just give this to Camel and it's going to transform the body. And then we want to transform it again to JSON. We'll use Jackson. So here, you tell me if I have the wrong one. I've never know if Marshall or Marshall or Marshall. And then I'm going to push it to Kafka. So my IDE doesn't like the choice. And Kafka.
Okay, so and now when you are going to hit save, is it going to crash because there's no Kafka? You haven't started any Kafka cluster.
No, it's going to work because I'm in Quercus developer mode and they have dev services. They have several databases that when Quarkus, we are on dev mode and this database or this Kafka is not configured, which is my case today, it's going to use test container and load for me a Kafka. And also it will push this URL of the Kafka broker in my app, and it will work as magic as it is. I don't have to install anything on my laptop.
Okay, so Quarkus Dev Services exist for Kafka, several databases, and several other external systems. You just add the Quarkus extension into your POM XML, and Quarkus knows or may figure out that you need a container to work in the development mode, which is pretty nice.
So it's still working. Let's do the second route. Begin actually consuming from Kafka. Just to get the same name of the topic, Telegram message is the name of the topic that I chose. I can log the incoming message. Incoming from Kafka, and I will have it in a JSON format. Ready. And we wanted to send it to an S3 bucket. So to AW.
As we said earlier, the credentials for the S3 bucket and the name of the bucket are stored in application properties. And there, because we use only environment variables, Quarkus developer tooling is able to pull them from the environment where Zineb has them defined.
Yeah, so I'm getting the name here, and as you saw here, we have the access key, secret, and etc.
Okay, have you saved it?
And let's try
I'm gonna send some real messages now because they are really stored now.
No, I have an error.
Oh, what's the error?
Oh, the key header. So yeah, I have another line.
And this is also
that
important
I don't know by
to
heart.
see what happened if there's an error. Quarkus daemod just outputs what's the error. You can fix it, hit save, and it recompiles, and if everything works, it works.
So the Amazon S3 needs a key, and we chose to put it on a header. So here, because it's just a simple one, I am getting the set header. So at this moment, we have a body, but we're gonna add a new header. This header is a camel header, and I'm just having a UID. So so now it's live reload, and do I have my again? Yes, I have a Telegram. I don't know if you can see this. I have my text again, username. Yeah, I have Peter also here. So this is the end of the demo. It was very quick to build this one. No, it's not finished. So this is the dev mode. If you want actually to build the Java app, it's like the usual Java app. When you want to build the native mode, we're going to use a profile that is already available in the pam.xml with the app that we generated. So we just do a Maven package and use the native profile.
Please note that there's no special mention of GraalVM in the command or in the configuration. Everything is done under the hood of by Camel extensions.
Yeah, it generates this line with native image. We don't have to write all the stuff so that it could work.
Okay, this will take quite long. Zineb has it already compiled before this talk, so we can just show you the result because we have 19 minutes left.
Yeah, so let's go check the app. I can give it an XMS just to try. Already.
So have you seen how fast it booted? If not, we can do it again. This fast.
We don't see really. It's so yeah, it's 0.100 something. So yeah, it's really fast. Maybe you can send some messages to see a little bit how in the the memory. Here it's still compiling. I have my notes here. Just to have this app actually doesn't use the only difference is that it doesn't use Kafka because I didn't install it. So it goes from Telegram to AWS S3. So here we have.
In the second column, this is the amount of RAM spent by the process in kilobytes. So we are under 100 megabytes here.
So I can try the same with JVM. So Java using the same.
I sent some messages.
Yes, I see the messages. So let me check this one. And here we have the twice of memory usage. Just to know that this memory is going to depend actually on how many extensions. Here we already have a bunch of them, but it will depend actually on the app, what kind of extensions do you have, how many amount of the extent, what does, and also on the extensions. But for this app, we see that we already have a difference when we compile it in JVM or in native mode.
And we have limited the size of the memory pool. If we wouldn't do it, the memory would rise much steeper with the new requests, and it would take longer till the garbage collection kicks in.
Yeah. So I'm going to move on because we have the second part up. This one. So I'm going to be very quick because we still have the second part. How can we deploy on Kubernetes? There is here a video on Quarkus Insights that is a talk about how to do it. just to know, there is so many, these are the Quercus extensions in order to build a container in different types. Here you can generate resources depending on the flavors of Kubernetes. So yeah, I will invite you to see this, or just come talk to us later, because we have to keep going. Second part, do you need to?
Okay, now we switch the monitors.
Yes.
Hopefully
If you
it's
have
gonna
a
work.
if you have a question while we switch, I hope it's gonna work. Yes. There's maybe a microphone.
I can speak loudly. Quarkus, you said you can usually uses Mandrill that is provided by Red Hat, but you also stated that Apache Camel actually uses GraalVM under the hood.
Yes, because here what we're showing is the community version. So we have a GraalVM, and Mandrill is yeah. The question was like we said that we can use Mandrill, but in the community version we saw here the GraalVM. Mandrill is a distribution of Red Hat for GraalVM. So on community side, it will use GraalVM. In case you have you use the Red Hat build of Quarkus, and you use the Red Hat build extensions of Camel, you will use Mandrill. So this is it. Is that work?
No.
So maybe you can try on my laptop, maybe. We speak different languages, so we have different flavors of keywords, keyboards.
Still nothing.
Yeah. I think you can switch to mine. It's hopefully it's gonna work again. I have a. No, you're gonna fail. Let me help you.
Okay.
Yeah.
I think in the beginning, Zineb has shown the BOM XML file in her demo application. That file contained the BOM and the individual extensions. Actually, when you look at the definition of the Camel root, it's pretty much self-explaining for the people, but also could be self-explaining for machines. Because when you look into the DSL and so on, it's pretty limited scope of possibilities, and a program could be written that is able to assign or to figure out which Java artifacts are needed to run a given Camel root definition. So this is the idea behind Camel K. You write your root definitions in flat files. You could do it with Java, but in that case, you would have to have that class and method declarations around the code. But if you use Groovy, you even can omit that, and you could use also JavaScript, for example. So, and in the second step, you take the Camel, written with K, command line tool that takes your flat root definition file and pushes it into a Kubernetes or OpenShift cluster. And now, how is the cluster supposed to figure out what artifacts are needed to run this using Java? And the answer is this. But, and this is an operator, a human operator. Inside the cluster, we use a piece of code that is called operator. That piece of code is running inside a container, inside the cluster, and that one is able to analyze the root definition that we have pushed and just build the container image that encapsulates your root. So, Zineb, how do I now show my roots?
Hopefully here. Yeah.
No,
So you need the developer.
no, I want
The-
the administrator first. Let me do it
Yes.
second.
Go ahead.
So this is the administrator view, and here I can have a look. This is OpenShift on Kubernetes, on plain Kubernetes. This would be similar. You would have to install two operators for running this demo. First, it's the Camel K operator that you can install directly using the Camel command line tool by running Camel install. And second, you need the Knative operator, which is called Red Hat OpenShift Serverless on OpenShift. But that just brings the Knative stuff. So we need these two to run this demo.
Yeah.
And then when we get back to the developer view inside our project, where do we have the roots?
The Camel K is here.
Yeah, here. So these are the root definitions that I'm going to use, but I actually had a slide showing what I'm going to do. Yes, I'm going to take the messages Zineb's demo has stored in an AWS S3 bucket. I'm going to push them into a Knative channel. I'm going to explain what a Knative channel in a moment. And then I'm going to pass them on to a Google spreadsheet. Could you open that spreadsheet? Probably not, because you are not in the VPN. Or could you?
I think I can. But
Everything is ready on that computer, but I'm not lucky.
don't look at my emails. This one. No, not this one. Another one from Peter. This one. Sorry for the rest.
Okay, so this spreadsheet is empty initially, and when we deploy these routes that are implementing the message exchange, it should slowly be filled by messages. So when I'm going back here, I can see the two. Is one of your
I don't know if
demos still running?
It's connected or not. You are on Camel K demo. If
No. I need your demo running so that if anybody sends new messages, so that they are coming.
It's still running here.
Okay.
So yeah, you can.
So I can see the two. Okay, directory here. I have my route definitions here. Before explaining what's inside, in 8 minutes, I will just deploy them. So I say Camel on French keyboard, run, Knative to Groovy. Where is minus? Here. Perfect. And cd. Okay.
Yes.
Okay. And I'm gonna deploy.
So Camel is the Camel K actually client CLI. So when you use the Camel K operator, so we saw actually the Red Hat version because we are from Red Hat and using OpenShift. But of course, if you use actually community version, you can have the Knative community version because it's an open source project, and you can also have the Camel K community versions. And you install the Camel CLI so that you can run it from your laptop. And as you see, when I did OSE project, OSE, it's the kubectl command line, kubectl, I don't know how we say it in English, for OpenShift. So we were already connected to the cluster.
Okay, so both routes are deployed. you can see that they are deployed in a slightly different way. One of them is a standard OpenShift deployment, which is not serverless, right? And why? Because when we look into the definition, it's this one.
Try to get it bigger, yeah. It's okay, it's okay.
It's this one. What have I done?
Yeah.
The Camel K operator sees that we are using this consumer, and it knows that it needs to poll the S3 bucket in regular intervals to find new files being stored there. And if this would be scaled down to 0, there would be no polling and no messages would flow in. So Camel K is smart enough to figure out this, and that's why it deploys this specific route as an OpenShift deployment. But that's not the case with the other route, which is this one. That one consumes from a Knative channel, and that channel is something that can awake that route, and that's why Camel K operator chose
to deploy it as a serverless
as a Knative service. And now at this moment we see that this is scaled to 0. So when I'm now going to send some messages from here,
make it from here.
It should wake, and we should see the messages appearing there.
Yeah, so these, like, we saw that they came a little bit.
And when we get back to the view,
and
we
it is
should
running.
see that it is blue.
Yeah, it's blue.
It will scale up without us doing anything. And when we don't send any messages for a while, it will scale down to 0, which is a perfect definition of serverless, right? Now, about the Knative channel, that's this little thing. The definition of it is stored here in the demo folder. It's pretty basic. It's just the default Knative channel. If you don't specify anything custom here, it just creates an in-memory channel. But if you would like, there's an implementation backed by Kafka, and you could get this backed by Kafka. And having said that, Knative channels are pretty much like Kafka topics. That's what they do. So now, how much time do we have? I'm not going to explain how the routes are implemented because we have no time. I just switch here to the spreadsheet. You see that the messages arrived here, and that's what we wanted to implement. Now let's get back to the.
Let me put it
to the presentation.
So yeah, it's a wrap up. So what we see here today is an Apache Camel is an open source integration toolkit that have more than 350 connectors, and we say that we can connect to almost everything. It's a supersonic, subatomic, and we have the developer joy on Quarkus. I don't have the last version. We had another thing, and then it can scale to 0, and we can deploy it very easily to Knative. And we show also that we can stream data from and to Kafka very easily. And these are some of our links, and we will put on our Twitter the link to the slides and that contains the link to the demo. These are some other talks that we have today in this Dev Nation.
No. First, don't forget to read this talk.
Yeah.
And then there are more. There's more interesting Quarkus and non-Quarkus related content coming in this room, as a part of Red Hat Dev Nation Day.
Yeah.
I think that's it.
1 minute.
Thank you very much. If you have any questions, come to us now. or meet us at the Red Hat booth today, the whole afternoon. I think we are going to stay there. I have posted the slides on my Twitter handle that we still can't see here, but if I'll be able to switch. Okay, my Twitter handle is here on the first slide. So if you check my Twitter stream, the slides were posted there already, if you want to see them.
Yeah. Thank you.